Hello, today I want to talk about the Monty Hall problem. It's a super famous probability problem, and I'd be surprised if you hadn't heard of it already. But understanding this well literally helped me during an interview. And if nothing else, this is a great chance to get some practice with fractions and percentages. Okay, jumping right in, I'm going to say without loss of generality that this door is the one we pick. And so that's going to be 1/3 chance that the car is here. Okay, now what's the chance that the car is over here instead? It's 2/3 distributed evenly across both doors. And then your host comes along and opens one of these doors, revealing a goat. Okay, now this 2/3 is no longer distributed evenly across these two. This one is gone, and so the 2/3 is just assigned to this door. Okay, so we want to collect a few different stats from this. So what's that going to look like? Well, what's our chance if we win if we stay? That's 1/3. What's the chance we win if we switch? That's the 2/3. So if we have the numbers 1/3 and 2/3, there are a few different ways we might want to compare these numbers. One way might be to say that this is 1/3 bigger. So to get from here to here, we add 1/3. Another way might be to say, to get from here to here, we have to multiply by 2. And then another way we like to compare things, often you see it in stores with something that's like 25% more value or 50% bigger. To get from here to here, in that case, would be we are 100% bigger. So we have a lot of different ways of saying how much bigger this number is, but for our purposes, I would like to use the verbiage of it's an increase of 1/3 and an increase by 100%. And those are the numbers I would like to use. So this increase of we'll call the difference, and this increase by we'll use a percentage. And it doesn't quite make sense to use a non-percentage for this number because we'd be saying an increase by 1, which I think is very misleading. So to that end, we won't fill in this box and we'll go ahead and say the difference is 1/3 and it's an increase by 100%. Let's go ahead and fill in these other values with the percentages. So the win if we stay, let's round to one decimal place. So we'll say 33.3%. And the win if we switch 2/3, that's 66.7%. So the difference between these two, also 1/3, so 33.3%. So now we have what I think are the interesting stats of this problem. And so if you have someone who's currently in the game show, they've eliminated one and they're thinking about switching, well, you can tell them that if they stay, they have this chance of winning. If they switch, they have this chance of winning. The difference is this and the increase is this. Or we have our strange verbiage where we have the increase of 1/3, but the increase by 100% because your chance goes up from 33% to 66%. So I want to play this game again, but with 4 doors. So let's take a look. Okay, again, I'm going to pick this door. That's a 1 out of 4 chance that the car is here. And then over here, that leaves a 3 out of 4 chance, split evenly, that the car is on this side. Our host comes along, reveals a goat. Now, this is no longer an option. So this 3 out of 4 is only split between these 2 doors. So what's the chance that this door has the car? Well, it's that 3 out of 4 and it's split 2 ways. So we multiply by a half or divide by 2, same thing. So that's 3 out of 8. So that's a 3 out of 8 chance that it's behind this one and a 3 out of 8 chance that it's behind this one. So our chances go from that 1 out of 4. If we switch to either of these, then we get that 3/8. So let's look at our numbers. So the win if we stay is that 1/4 and the win if we switch is the 3/8. So let's figure out those things we had last time. We have 1/4 and 3/8. So last time we had that plus something, we have that times something, and we have that increase by some percentage. Let's remember last time that we had that 1/3 and the 2/3, and this is either plus 1/3, could be times 2, or 100% bigger. Okay, so where did this come from? Well, that's just subtracting the 2 of these. Okay, so let's subtract these. We have 3/8 minus 1/4. We need common denominators, so that's 3/8 minus 2/8, and that's 1/8. So this plus is 1/8. That's a difference of 1/8. Okay, how do we fill these other ones in? So this times 2, where'd that come from? That comes from if we divide this by that. So let's divide these. We have 3/8 divided by 1/4. To divide, we flip and multiply. So 3/8 times 4/1. Across the top, that's 12/8. And we can reduce that to 3/2. We reduce by 4. We also could have reduced earlier if we had noticed that over here. And so this number is 3/2. So how do we get this number? Well, we can either take 1 less than our multiplier or compare this number to our original number. So let's do that by taking our multiplier and subtracting 1. So that's 3 over 2 minus 1, which is 3 over 2 minus 2 over 2, which is just 1 over 2. And that's going to be 50%. So that's our increase by 50%. And remember, we don't fill in this box. So now we just need to convert these to percentages. That's 1 over 4 is 25%. Okay, 3 out of 8 might be a little tricky. Let's try it out. So we have 3 over 8. To convert, we do times 100% over 1. Let's reduce these both by 4. So 8 becomes 2 and 100 becomes 25. So we have 3 times 25 across the top, 75% over 2. So let's divide 75 by 2. That's going to be 37.5%. Okay, 1 over 8, we maybe already know it, but let's work it out. 100% over 1. Let's do the same thing as before. Let's reduce by 4. So we have 2 over here and 25 over here. Across the top, we have 25. And on the bottom, we have 2. 25% over 2. That's going to be 12.5%. And so we have all of our numbers for 4 doors. All right, let's move on. So it might look like we're still seeing 4 doors here, but what we're actually saying is that in this gap, there can be any number of doors. So we want to consider this to be n doors. There are as many doors as we want here. It could be 10 or 20 or 100 doors. And we want to find those same numbers, but use n in our calculations. That way, it's generalized. So let's do the same thing as before. We'll consider that we pick this first door, and what's the chance that the car's there? It's 1 over n. So what's the chance that the car's over here? Well, it's 100% or 1 minus 1 over n, the chance that the car is under this one. So let's simplify 1 minus 1 over n a little bit. That's n over n minus 1 over n, which gives us n minus 1 over n. Okay, now say the host comes along and opens one door and reveals a goat. This n minus 1 over n used to be distributed across all of these. But now it's removed 1, so it's not distributed across all of them. It's distributed across 1 fewer. Before the door was opened, each door had a probability of n minus 1 over n divided by n minus 1. If we flip and multiply this, that's n minus 1 over n times 1 over n minus 1. These cancel. And that's 1 over n. That's exactly what you expect, right? Every door has 1 over n. So that was the before case. Let's see after. So after, it's not split n minus 1 ways, it's split 1 less. So n minus 2 ways. And so now we do n minus 1 over n. And instead of dividing by n minus 1, we divide by n minus 2. So when we flip and multiply, we get n minus 1 over n times 1 over n minus 2. Now when we multiply, across the top, we get n minus 1 times 1. So that's just n minus 1. And on the bottom, we have n times n minus 2. N times n minus 2. And so this is our chance if we stay here. And if we switch to any of these doors, we get this. So let's try filling in some of our numbers here. This is 1 over n. And this was the other value over here. So we have 1 over n. And we have n minus 1 over n times n minus 2. And what do we need to add to get from here to there? It's the difference, which is this minus that. So let's do that. N minus 1 over n times n minus 2 minus 1 over n. Okay, to get common denominators, we need this side to have that n minus 2. Let's do n minus 2 and n minus 2. So on the bottom, we have n times n minus 2. And on the top, we have n minus 1 minus n minus 2. Okay, when we distribute the minus, that's going to give us n minus 1 minus n plus 2. The n's cancel. We just have negative 1 plus 2, which is 1 over n times n minus 2. Let's go ahead and fill that in. We have 1 over n times n minus 2. Okay, let's remember how we did the increase by. So first we found what we need to multiply by to get here, and then we subtracted 1 from that to find our percent increase. So how do we find this multiplier? Well, we divide this by that. So that looks like n minus 1 over n times n minus 2 divided by 1 over n. That's the same as flip and multiply. So this flipped over is just n, so we'll just multiply by n. That's n minus 1 times n over n times n minus 2. So this n cancels with that n, and we just get n minus 1 over n minus 2. So this is our multiplier. So this is just going to be 1 less than that. So we do n minus 1 over n minus 2. We subtract 1, but this 1 to get common denominators is going to be n minus 2 over n minus 2. So on the bottom we have n minus 2, and on the top n minus 1 minus n minus 2. Looks pretty familiar. When we distribute the negative again, we end up with n minus n and negative 1 plus 2. So on top we just have 1, and on bottom we have n minus 2. And since we want this expressed as a percentage, we can multiply by 100%, or we could just put 100% on top. Okay, again, we don't want to fill this in. And then we can convert these. I don't think this is better, but if we want, we can put the 100% on top. And this one would just be that thing, but times 100%. Okay, I just want to use these 4 values and look at those across our different scenarios that we've drawn up here. So probably the easiest thing to do first is just look at this column. So if we have that 1 over n, if we stay, for 3 doors, that's going to be 1 over 3. And for 4 doors, that's going to be 1 over 4. Great. For the when if we switch column, let's go ahead and think about that one at a time. So let's think about n being 3 here. And so if we have n minus 1, so if that's 3 minus 1, that would be 2 on the top. And then n being 3 and n minus 2 being 1. So that's 3 times 1. So that's 2 over 3, which we have here. Okay, now if we think about it being 4, so 4 minus 1 is 3. And then 4 times 4 minus 2, that's 4 times 4 minus 2 is 2. So this is going to be 3 over 8. That's our 3 over 8. Okay, now let's think about the difference. So if we have n being 3, then we have 1 over 3 times 3 minus 2 is 1. So this is 3 times 1, which is just 3. That's 1 over 3. Great. If we think about n being 4, then we have 4 and n minus 2. 4 minus 2 is 2. So 1 over 4 times 2 is 1 over 8. Great. Okay, let's think about our increase by 100% over n minus 2. For 3 minus 2, that's just 100% over 1, so we get that 100%. 100% over 4 minus 2 is just 2 on the bottom, so 100% divided by 2 is 50%. Great. So we've double checked that our n doors works with 3 and 4. I think a good exercise would be to just pick a number from like 5 to 10 and plug it in and just see what those numbers get. But right now, what I want to do is something a little bit more fun. We're going to jump to 100 doors. So what happens if n equals 100? So even before we jump into the numbers here, just want to think about just intuitively what's going on. So if we pick a door, our chance is 1% that the car is here. And then after our host opens a door, then we're still picking from about 100. So the chance if we switch to another door, to any of these other doors, the chance of getting the car is still about 1%. So hopefully our numbers reflect that. So let's take a look. Okay, so we're saying n is 100. So that when if we stay, that's going to be 1 over 100. When if we switch, n minus 1 is 99 over n is 100. N minus 2 is 98. For now, let's go ahead and leave it like that. Let's do the difference. We have 1 over n is 100 and n minus 2 is 98 again. And that increase by, we have 100% and n minus 2 is 98. Let's look at those as percentages. So 1 over 100, that's just 1%. To convert this one to a percent, I'm going to multiply it by 100%, right? Which is going to then cancel with that. So I'm going to be left with just 99 over 98. And that means I just have 1 and 1 over 98%, which that's going to be about 1.01%. In this case, we know it's just the difference between these two. That means when we take this minus that, we're just left with this fractional piece. So this is just that 1 over 98%, or about 0.01%. And 100% over 98, that's 1 and 2 over 98%, which is about 1.02%. And so this really lines up with what we were saying before, right? We have that 1% at the start, and then if we switch, we have a very slightly higher chance, and that's an increase of this much, or increase by about 1%. A very small increase if we switch. Okay, that's all for now. Some things you might want to try on your own. What is going on with the case of n equals 1? Or n equals 0? Or 7.5? Maybe even try having the host reveal 2 goats. Okay, have fun, thanks.